Hello, and welcome to the tips and tricks video on using AI to help you with your selection prediction. I'm Scott Felber from the Designcenter NX product marketing team. And in this video, what we're going to do is we're going to look at how to use AI with our selection prediction tools to help you do your everyday tasks, whether this is decluttering a large assembly or using select similar faces and edges to do object action type operations on large sections of your parts at once. Let's go ahead now and get started with our demonstration. Let's say now we're an automotive engineer working on this car, but we work in the structural area. So what we want to do first is get down to the area of the assembly which we want to work in today, which is going to be the lower half of the structure. Once we have only the lower half up, we'll zoom in and we'll notice there's quite a few fasteners also in this part. Today we're only concerned with the sheet metal structural parts and not the fasteners. So what we'll want to do is use what's called select similar components to go ahead and bring all those components together and eliminate them from the display. When we first select similar components and we have a component showing, it will run the similarity engine to go ahead and process all the parts to be able to find it. The benefit of letting this selection engine run at time of selection is it doesn't store additional overhead in the part for opening. You may choose to turn that setting on if you do this quite often and want to save that time at that part of the thing. You can see now the engine has run. We selected one part and all the other parts that are available are in our tree over here that are very similar to the one we first started with. So what we can do is we can scroll down the list and using standard Windows keys of Shift and Select, we can select now the top ones off the list. And you can see now we have 86 parts all selected. And we can scroll down and some of these other ones look like brackets and other ones we may not be interested in. So we can take those selected components and say, okay. Once we do this now, because we're doing object then action, we see that in this command prediction toolbar, we can hide all those parts because this is a workflow I do quite often, so it's predicting my next commands. I still see there are quite a few fasteners left, so I'm going to reuse the command. Again, now that all the parts are processed, it doesn't have to run that engine a second time. That is a one-time operation. I go down and it finds all of these parts. Again, I have about 155 of them selected right now. I go ahead and say okay on those. And again, object, action, I'm going to remove them from the display. Finally, we have a few bigger ones left, a little larger in size than some of the original ones we selected. So let's do this just one more time to kind of get some of these bigger fasteners kind of out of the display. These ones have bigger heads, I think, than some of the first ones we picked. So we go ahead and pick a few more off the list, and we'll go ahead and hide those. So again, I'm doing this workflow. I do this one quite often, so my command prediction helps me along the way. Now that I've hidden all of these connectors using AI-based methodology, I'm going to go ahead now and see what I have hidden by reversing what I'm showing and not showing. You can see now, here's all the parts that I was able to pick with those few clicks. What I want to do now in the context of my work is I want to go ahead and create a component group that just has this ad hoc set of parts all together into a filter that I can turn off and on quickly. I select them all, give my filter a name, and I'm just going to call this one fasteners. And now when I save my part moving forward, I won't have to redo this work. I can continue to use it. And you can see I selected 262 fasteners, components, very easily. So what can I do now? Well, now that I have them in my assembly as a filter, I can turn off all of these parts I picked easily and quickly by turning off on and off the checkbox. As you can see now, all the fasteners are turned on. When we go ahead and turn off the checkbox, it turns them all off and on. Again, like I said, if I save this fastener group now, I can then use it in my future sessions of NX. Now that we're done using components, let's go ahead and look at faces. We want to work on these little like cup dimples, I call them, for structural members. And what we want to do is we want to find these all and maybe color them to a certain color to help us with selection later or for a coating or painting. So what I want to use select similar faces. So what we do here is we go ahead and start the command, and I'm going to give it a scope to say find everything in the entire assembly. And what I do is I pick the faces I want it to find. So using region commands, I select a seed in a couple of boundaries, and I get this three-face region right here, and I'm going to have it go ahead and search the entire assembly. Again, there's hundreds of parts here that it's working through, and what it's going to do is going to come back and bring back all of the feature groups that have three faces and are of similar base construction, I'll say. So you can see now we have, I don't know, let's scroll down to the bottom. You can see all the orange ones, but if we look at our list, it found 84 regions. Now by adjusting sensitivity, I can increase or decrease that number if there are more candidates available. What I'm gonna do is with object action, I'm just gonna pick all these for now, and I'm going to go ahead and color them to a color I'd like to use later on for selection or coatings or, like I said, other things maybe. So let's kind of go take a more detailed look on what this is really kind of doing. And we'll go first in this middle area here. And you can see there's some ones on the left side of the screen, but there's some underneath this other bracket. I'll turn that off for now, or this other structural member. And what you'll notice is they are of different sizes in this area. You can see the ones to the right-hand side are a little bit smaller than the ones to the left-hand side. And again, by adjusting sensitivity and other things, I can include and disclude things when I kind of do this work. What I'm going to do now is kind of scroll up to the front area a little bit. And you'll see ones that look very similar that weren't being picked. But if you look closely at them, they touched another edge which created more faces. Those ones have 4 faces. The one thing today with select similar faces is it needs to have the exact same amount of faces. So those ones that have 4 faces aren't the same as the ones that have 3 faces. Let's continue on with just another ad hoc, what I'm going to call ad hoc query here on this slot. This is like a standard slot. So I'm going to go ahead and pick, like before, I'm going to say, go ahead and find a slot part within our assembly. And again, it gets 4 faces, a standard slot, 2 flats, 2 rounds. And I'm going to go ahead and say, find everything you can. And through action object again, I'm going to go ahead and color those all to a certain color. Again, using sensitivity, I can increase and decrease. This is all doing this very ad hoc. And as a user, maybe I want to do this where I just want to find what I want to find and not kind of worry about creating standard sets of faces that maybe we do manufacturing operations on or other things. But I'm going to go ahead now and just pick these slots and get them colored. Because what we want to do after we do this one is we want to go ahead and create a standard search criteria so we don't have to do this all the time. And that's very simple to set up and do. Once we get these all colored to the appropriate color, we'll take up one of the parts that has a slotted hole on it. And I'm going to do this in a piece part mode as I create my master one. You can see now all these ones that I just found. But we're going to go up here now and use some of these slots here now to create a library member. So we'll go ahead and just bring this one up on the window by itself. And using the reuse library, there's an option now to create a region that we want to use. So we can see now we have a slot. And notice the thickness of the sheet metal in this part. This is going to come into play later, but this is kind of a little bit thinner size. That's going to matter later on in our demonstration. In my reuse library, I have a shape library. I have one called slot, but I have nothing in my slots today. So I'm going to go ahead and say define a shape region. Again, I use it like I did originally. I tell it the rules to create the shape. Again, it'll pick these 4 faces. I give it an appropriate name. I'm going to call this one slotted hole. I give it a nice picture to help people be able to find it. Again, by using the region command, I'm going to window select around so I get a nice image, which will then appear in my reuse library. And then the one thing I'm going to do also is I'm going to name the faces it found. I have 4 faces, and up on the top, you can give these custom names. This is really important. Sometimes people do manufacturing operations or other operations downstream based on names of faces. So by finding a standard shape and giving it standard names, I can apply automation now to these kind of shapes throughout my enterprise's way they do work. So now I have this shape all defined in the shape library. I'm going to go back up one level where we're kind of working. And instead of executing select similar faces from the command we were doing it before, when you're in the reuse library now, you can just click on it, use your third mouse button and say, find this shape. And then we'll get that same dialog we had before, but instead of prompting you to define the shape, it already knows the shape you have from the object. And this time, instead of doing the whole entire assembly, I'm just going to do these 2 parts here. And what you'll notice is, at first, it doesn't find them. Again, it's that thickness and the width of the slot and a lot of other things that can increase and decrease with sensitivity, right? So as I increase it, I get more or less. But you'll notice now I have those names that I assigned in the original one. When I was talking about the thicknesses, here's a part that's quite a bit thicker from a slotted face and quite a bit different in length, but you can still use it here with sensitivity. So let's go ahead now and say find it. In this work part, it finds nothing. But if I decrease the sensitivity, you'll notice now I'll get it. It would have those same names and everything else. One last thing I can do is I can also do this with edges. So we have a command called select similar edges. Let's say I need to apply a chamfer, and I know there's a lot of the same shapes in there. So I'm going to use my selections to do object action again. And I'm going to say select these 3 edges along the top, and I'm going to do a search in the work part. It finds multiple candidates, but if I adjust the sensitivity to 100, I get exact match. What I want to do is only do that edge on those 4 corners and not the other ones. They're all selected. Again, using command prediction, I'm able to chamfer off those edges and continue on with my work. Makes my workflows very easy and very simple to do. And again, it helps me be more productive by decreasing time I need to do stuff. So really, what do we see here today? Select similar components and select similar faces and edges are all part of our AI tools that help users become more productive. It uses machine learning underneath to help you go ahead based on the selections you give it to interrogate your data and find the similar items. By doing this, you can then do object action type modeling commands and other things to your parts to help you become a more productive modeler and more efficient so you can concentrate more on your engineering task. Once again, thank you for watching this how-to video on Designcenter NX. Thank you.